have is the following picture a relation, is the following relation a function and justify. So again, part A, it is a function, and it is a function because it passes the vertical line test. So we would say it passes and then the vertical line test. Now part B says give the domain of it. Now when we look at the domain of these, oops, not D, it's part B, and it's capital D for domain. So when I'm looking at the domain, so the domain on this one, we have to look at the values for x's that could possibly be coming into play here. So we see that this keeps going up and up and up this way and up and up and up this way. So eventually, no matter how far we go out this way, we would still be able to follow up to that graph somewhere. So the domain here, we shouldn't be using a roster form because we can't describe real numbers with a roster form. We should be describing this with just the real number symbol. And then part C with our range. Okay, the range on this one though, you see the farthest it ever goes down is right here, and then everything up from here you could follow over to the graph. So this one is a -1 as far down as we go. So -1, and -1 is actually included, and then it goes up to infinity, just like that. And then in part D, it says find f of 0. Well, f of 0 is when x equals 0, what is y equal to? So x equals 0, follow it up to the graph, and we see it equals to 2. So it's 0, 2 is our ordered pair there. So in other words, f of 0 is equal to 2. Now in part E, what we're looking at is finding f of x when x when f of x is equal to 0. So this says when y equals 0. So y equals 0 here. So there's a point there and there's another point here. So x could be equal to this point here, which is -1, 2 over, so -2. Or x could also be equal to -5 right there. And so those are our two positions. And so remember that this point is actually a special point. This one is called our y-intercept. Remember that when we're finding f of 0, that's our y-intercept. And this one down here, these are the way that we would look at the x-intercept. And it's always important that we know how to look at x and y-intercepts when we use those function notations. All right, problem number 10, we're doing a little bit of evaluation in problem number 10. And so we have f of x being something, and then we have putting that value in for the x. So f of a minus 4 is 3 minus 5 times, and then we're putting a minus 4 in here. And so now we have a distributive property here and here. Don't forget that it's a negative distributing through there as well. So we have 3 minus 5a plus 20. And so now we combine our like terms here and here. And so now we have 23 minus 5a. And then our next one is f of x is equal to a -7. Well, now this isn't evaluation. This is saying that this is what the equation equals, or the function equals. So this says 3 minus 5x is equal to a -7. So that means we're going to solve an equation. So -3 there, -3 there. So -5x is equal to a -10. And then once we have that, then we multiply by the reciprocal here and here. And once we have that, then we have our value for x. So x is equal to +2. So in other words, we have f of 2 is equal to -7. And that would be our solution in that one. So not only can we evaluate with function notation, we can also do a solution of an equation through function notation.